Yeah, you have to file.
Yeah.
But why did you know it? We just needed to upload an unofficial one. All you had to do, because I seen that too. I'm not gonna pay $9 to send it to myself. Why did you ask me? I would have told you how to do it. All you had to do was share it, email it to yourself on not view grades, but like on the thing on banner. Just share it to yourself, and then you could have clicked that little box that we have an arrow that says share. Once you click it, you could have saved it to your file. And it would have been an unofficial transfer. That's all they needed. Should have asked me. I ain't spending $9.
Well, I already bought it, so I can still do it.
Yeah, but I had to spend all that money earlier this year. Send it, asking me for $15, $20, $30. Oh, what's a transcript? Y'all know how to get free transcripts?
Yeah, welcome in everybody. If y'all seen anything where physics has applied these past 2 days?
Haven't seen anything.
Yeah. Anything that came up during your studies, or anything that you?
Oh, my everyday life.
Yeah.
I mean, the train road has.
All right. Sounds like some time dilation. Sounds like some velocity was applied. We had some friction in the tires. You heard some screeching because the brakes were trying to overcome the frictional force. Or not overcome, but the brakes were being supported by that frictional force where it was screeching. That's probably the friction that you were hearing, and then it's going some velocity, and that's a big amount of mass. So that mass plus that velocity probably had a lot of work that it had to put into to make it stop over that amount of distance. Right. Sounds good. That's what I heard.
You restarting your computer?
It's up now. I had to use my hotspot, whatever. But all good. So these are, y'all want to go over the homework? I was thinking we could go over the homework, and then we could look at those worksheets that he provided. You can see for that has to do with our chapter. There's a potential energy experiment with the marble. So maybe by the time we get done with these two, then we'll be in our lab portion after lunch. And then we have something talking about potential and kinetic energy with power and work with our potential and kinetic energy.
Oh, good.
Which the addition of potential energy and kinetic energy, what's the equation for potential energy? Work.
Oh, I forgot that.
Yeah, potential energy. If we look at our book. Talking about work. So we're looking at work. So we'll see that here in our video here.
into motion signals the beginning of a very exciting ride.
Wow. What's up with the internet, y'all?
The jolt into motion signals the beginning of a very exciting ride. With a name like the Intimidator, this roller coaster gives thrill seekers a chance to experience physics without even knowing it. The lift of the tracks adds gravitational potential energy, the energy of height. And on a stomach-dropping thrill ride down, this becomes kinetic energy, the energy of motion. And both of those make up mechanical energy. The higher the coaster climbs, the more gravitational potential energy it builds. After the train goes over the highest point, the gravitational potential energy is converted into kinetic energy, and it builds quickly. By the time the Intimidator reaches its lowest point, it is at a maximum pulse-pounding speed of 145 kilometers per hour, and its gravitational potential energy is now at a minimum. The many drops and twists and turns allow you to have a heart-pounding, close encounter with mechanical energy that you will never forget, but will want to experience again and again.
Yeah.
It says something about. It says something about something equals mechanical energy. What was
Yeah,
that?
it's only a
Is
minute.
it potential kinetic equals mechanical energy?
Yeah,
The
mechanical.
jolt into motion signals the beginning of a very exciting ride. With a name like the Intimidator, this roller coaster gives thrill seekers a chance to experience physics without even knowing it. The lift of the tracks adds gravitational potential energy, the energy of height. And on a stomach-dropping thrill ride down, this becomes kinetic energy, the energy of motion. And both of those make up mechanical energy. The higher the coaster climbs, the more gravitational potential energy it builds. After the train goes over the highest point, the gravitational potential energy is converted into kinetic energy, and it builds quickly. By the time the Intimidator reaches its lowest point, it is at a maximum pulse-pounding speed of 145 kilometers per hour, and its gravitational potential energy is now at a minimum. The many drops and twists and turns allow you to have a heart-pounding, close encounter with mechanical energy that you will never forget, but will want to experience again and again.
So let's
It's
see.
gonna be cold when you get through the winter too.
Oh man, it can't be because I did ask him something about that before. I was like, it's gonna start getting cold soon, and they said it's like seasonal. In certain seasons, they said, well, it's gonna be like that during the summer. So
Keep forgetting about that space heater.
yeah. All right, so. So we got this roller coaster here. And then we have certain ways that we could create a scenario. And chain.
Let me see this problem at.
This is a support. This is a lecture note for instructors for support with
okay, so you
this.
can only see it.
Mhm.
Oh, okay.
Yeah, with
Gotcha.
this. So we have a scenario that they gave us where we're actually testing out this exact simulation right here. This intimidator will be able to see the potential and kinetic energy. And then of course, acceleration, gravitation. Acceleration. We know that. Alright, so here's our scenario. What is its mechanical energy? Question mark.
So we're looking for mechanical.
Kinetic energy. The top of it. And also at the bottom of it. But there is an example, there is some type of example with this in the book. So since y'all read the book, should have seen this work. I believe it's on the next one.
Doing lab number 3 today, or is lab online?
Had it
So, yeah, I took
set up
some.
for online.
Oh, okay. I'll give you a practice.
Yeah. We could work on it together. Here you go.
The calendar.
So this is basically similar thing. Finding the speed of a roller coaster from its height. What's the final speed of the roller coaster? So this is connecting our work energy theorem and showing speed with height. So what's mechanical energy?
Mechanical
They
energy.
just
There's potential energy and kinetic energy.
yeah.
In the video.
Like, we see that.
Yeah. So we have our potential energy.
The potential energy would be going up on the roller coaster, right? Or is it potential
No, that's
energy?
potential energy right there, what I'm calculating. The roller
Oh.
coaster has the
Oh.
potential to go down.
Oh, before. Oh, okay.
And the kinetic energy is once.
Yeah.
things
The
are
movement
moving.
in motion.
Yeah, by train, be right here.
That's potential energy.
And then also at the bottom of the hill. Maybe it's probably actually this final speed right here.
Potential at the bottom too?
Well,
Yeah, when you, cause they gotta stop in that hump, well, in a way, cause like, the
Yeah.
thing gonna stop in the
Like
hump a
slowing
little,
down.
for a second,
yeah.
a slower movement. Like what you're saying.
Alright, so what are the forces, what makes potential energy? Or what's the equation for potential energy?
It's PE equals mass, gravity,
Yep. Alright.
Yeah.
H. And then kinetic energy. So we're at this potential energy at this point. And then as we go down, we're building what? Kinetic energy. So now we have our kinetic energy at play.
So the equation for kinetic energy is 1/2.
Yes. You're on the right track.
Meters.
Nope.
It's M though.
If it's in,
Mass. Oh, okay.
Stop saying meters. We ain't doing, let's do meters right now.
And then that velocity squared.
yep.
Yeah.
Cool, yeah. So and then we have, this is mechanical. So this is putting together some of the parts at the beginning of the chapter, work energy theorem, and putting it together. So this potential energy is converted to kinetic energy once we start moving. So now we can find the mechanical energy by plugging in what we have. We got a mass.
Mass of.
We should.
On that?
Yeah, there is one. It's a kilogram. My mass, coastal mass. Sorry about that, left that out. M, 1 kilogram.
Okay.
And they probably chose that just to be simple, because I'm gonna show you what a kilogram is. This is a roller coaster will obviously be greater than this. This is the force of a kilogram. 1,000 grams.
Huh. I don't know that's right.
That's 1,000 grams right there.
I think you
I think I'm really big.
Please don't put it
And then looking at our equations, we can even see we got our knowns and unknowns. We want mechanical energy, so we got this. We got our equation set up. What's our units? Equation with units. What's the equation of moving 1 kilogram over some distance?
That's miles per hour, ain't it? Or what was it? No, 'cause that
That would
has to do
be-
with speed, right? I'm not sure.
So we have. Let's see here. What's a good?
I just see the initial speed is. What's M over here?
Mass. Mass is a kilogram, right? Gravity, meter per second squared. Our height. Right now we have our height in feet.
Oh, my bad.
So it looks like we gotta convert this 305 feet
So what?
to, what's our SI unit?
Oh, wow.
To meters.
Oh,
Yeah,
meters.
meters. So now we have 305 feet to meters.
Hold on, wait. Oh, wait. Okay.
Okay.
Well,
So 1 foot, 1 foot is, I think it's the other way around.
How many meters is a feet?
Yeah,
Is it
0.3 meters. Yeah, 1 foot is about 0.3 meters,
Okay.
which makes sense.
So,
for the meter switch
305
right here.
divide. Somebody bought that calculator.
And then I have,
I got a couple of them.
Let me get one.
I wear a size 13, so
Don't mind anything.
1, 2, 3. So it really is 0.3 of a meter.
Oh, this is real. This one is very cheap.
Y'all see that?
Yeah. It's gonna be. It's say 1,016. Huh? Oh.
Let's see.
Let me just double check on this. I don't know about those.
So anytime we have height, we're gonna always change it to meters?
Yeah, meters is the SI unit,
Okay.
standard.
What is the limit? This is the- the 901 slide. I don't know.
So 305.
Maybe it was just right there. I did it.
Times 0.3, so I get 91 and a half.
See, I know it was wrong.
5.
I can do that though. I did the 5.
Yeah, 305.
Oh,
Oh,
multiply. Or
well,
divide.
yeah, it'd be,
Multiply.
yeah, multiply.
Multiply times 30. Sounds like a.
Because
Yeah.
we can test it out, if we write it out.
What's the converter?
We got 305 feet,
305 times.
and we want to get it in
Oh.
meters. So if I'm left with meters,
Yeah, I just typed the wrong thing in. So it's probably works.
91.5.
yeah, 0.3 meters is in 1 foot. So that means we can multiply by it.
So it's 91.5 meters.
So I get 1.5 meters. So I'll write that in purple so we don't get confused. Alright.
So we're gonna
So the
have,
height. Yeah, what's that?
it's gonna be 1 kilogram times 9.8 meters squared times 91.5 meters.
Yeah, let me
And then no, yeah, change. Oh, this is gonna be, oh,
let's finish the units first. Let's see if we get like some type of energy. Let's see what type of energy we get,
it's gonna be new.
so we can follow the steps. So this is a meter, right? Because height. So here's M, G, H. So height should be in meters, right? Alright, so now we got kinetic energy, 1/2 mv squared. Yeah, there's a 1/2 in there, but I didn't really matter for the units. Alright, so what's M?
What is it?
1 kilogram.
That's the kilogram.
Kilogram.
And the velocity.
Velocity is that the,
The initial velocity? What velocity you want? Because it says 17 miles an hour, but then we also got 145 kilometers.
So this initial velocity, the speed on the lift, that's going to be initial velocity. And then maximum speed, this will be once it's moving.
So much velocity.
We'll have to do, we'll have to subtract
Oh, final.
to get the
Oh.
final minus initial.
And that makes it, oh, no, they're not in the same thing. I was subtracting real quick.
So now go ahead and put this.
So what's 17 miles over an hour converted to kilometers? For
So that again?
what? What do you want from me? 17 miles an hour. So you want us to write the kilometers? Or do you want me to convert kilometers to miles over an hour?
Yeah, we want this to be in meters. Wait,
No.
kilometer per.
So miles an hour or kilometer an hour?
Oh, I see what you're saying.
I mean, I guess if you want to, somebody tell me how to convert miles to kilometers.
I think they gave it to us. Kilometer per hour. Everything. That must be. Must be kilometer per hour. I don't need to buy this computer. But we can still do the units. Yep, this is what y'all signed up for. We got a kilogram. Man, I hate signing into this computer. It takes a long time. It's like it'll look like it's going through, and then
And stop right here. Mom keep doing it too. That's all you want.
oh yeah, that's strange. And then I have to put in the code. Well, that must be kilometer per hour. So the next thing. Alright, so the next thing, we can go ahead and convert these to meters, meter per second. And then we need to convert this to meter per second as well. So what's the height converted to meters? That's next. We need to do that. We also need to do the speed converted to meters per second. And also the speed meter per second.
0.3 equals. Anybody want to give me a name before I get there? It's 90.
And I need to put how many miles.
No, you
Alright,
didn't
meter.
ask me that. You said, yeah, I forgot to move. That's for the elevation change, though. 300 feet is 90 meters.
Yeah.